Hello, this is Muzammil Malik. Here is my student ID. As you see, my student ID number is 4175334.
Hello, myself Rishiraj Modi, bearing student ID 4192721.
In these questions, we are going to perform dynamic malware analysis. So before performing malware analysis, we launch Process Hacker, Rexort, Process Monitor, and Wireshark. We are going to launch these four applications before executing the malware. And we will keep these four applications open during the malware analysis to capture the logs and behavior of malware.
After successfully collecting the initial information about the system before executing the malware, we execute the malware and we analyze. First, we'll capture the registry changes, and since the malware has had enough time to perform its malicious activity, we will perform the second shot button from the red shot tool and will compare and produce the output, where we can see that the number of keys deleted are quite high, but the total number of changes are definitely high. Next, we check the process activities by launching the Process Hacker tool, and we try to locate the malware process, which we fail to do so. We notice that we are not able to find the process even if we search under the Process Hacker tool's search bar. This is a very common defense and execution mechanism used by certain malware. Next, we go to the Process Monitor tool and we try to observe the process tree by clicking the Show Process Tree button, where the malware has already reproduced itself into two Windows processes named Red Services having PIDs 4680 and 5586. In order to see what kind of malware added, we click on the Red process that we have just observed, and following the path, we see that a .NET assembly has been created. Instead of running its own highly suspicious processes, the malware instead creates a suspended instance of itself and finally terminates itself. Finally, we identify the network activities by applying the HTTP filter in the Wireshark tool to list down any HTTP traffic generated by the malware to communicate with the C2 server. And immediately following the IP check, we see that the malware begins aggressively communicating with the IP address, where it requires highly sensitive cloud infrastructure data such as IAM credentials, ZIP API token, dynamic instance identity documents, which confirms the malware did not exhibit any C2 beginning. Instead, it acts as a credential stealer. Finally, we investigate the file activities by launching proc14, and we click on the funnel icon in the top toolbar and add exactly 3 rules, which we can see right here. So these rules are added, and we can see that it's plain blank, which further suggests that the malware executed and performed its network operations without triggering any single create file or write file event on the disk. For the overall behavior summary, the analyzed malware, it operates as a highly sophisticated cloud-aware credential stealer and consists of exactly 3 primary phases: evasion, stealth, reconnaissance, and theft. For the criticality assessment, we will classify the malware as critical. And finally, we use the virus total to finalize our findings. And the executables hash was queried against the virus total's threat intelligence database, which records a community score of 62 by 70, finally identifying the file as malicious Trojan or credential stealer. With this, we wrap up our demonstration. Thank you.